Well, hello everyone. My name is Giacomo Marino. I'm a bioinformatics software engineer in the lab, and I'll be talking about LLMs, ChatGPT in specifically, and hypothesis generation. So just as an overview of the lecture, we'll talk a little bit about ChatGPT and LLMs generally and their use in bioinformatics. Then we'll talk about how you use OpenAI models programmatically, specifically in Python. And then we'll show some examples of how we've integrated this into various apps that we've developed and using them for hypothesis generation with gene sets. So just to start, we'll be talking about large language models, which are built on these transformer artificial neural networks. And GPT itself stands for a generative pre-trained transformer. So it's very descriptive. It's going to generate new information. It's pre-trained on a large corpus of textual data, and the architecture is based off this transformer artificial neural network that works with an encoder and a decoder and looking at the context of tokens and their sequence to predict the next token. So in general, and I'm sure this is something that you've used or seen since it's been sort of widely adopted, the ChatGPT has many applications. Specifically, more relevant to our field are things like code generation, text mining, summarization and writing tasks, sort of extracting knowledge, and also sort of translation. So things like this, we've seen sort of ChatGPT applied to. If we look at so these are actually administered by or created by OpenAI, which I'm sure you know. So we'll be looking specifically at OpenAI models in this lecture, though obviously there are other options that you can consider, like Google's Gemini or Anthropic's Claude models as well, which are both also high performing. So if we look at a specific example of a sort of bioinformatics related task with ChatGPT, we might think that since ChatGPT has been trained on this sort of mass amount of textual data, which includes sort of abstracts from PubMed and potentially full articles on PubMed Central, that one application that it might be able to execute is extracting genes that are related to certain diseases. So in this case, in this first prompt, we're going to ask it to produce a list of 60 genes that are differentially expressed in men with alopecia. And we give it some information about how it should format its answer. And we receive an answer that has many different gene symbols, many from the same sort of family of genes. And it looks like a plausible enough sort of response that it's produced. We can ask it sort of a different but related question about genes that might be differentially expressed in women with alopecia. And we can see that it will actually give the exact same list of genes. So this might sort of falter our confidence a little bit about this gene list. And it might also just tell us that, well, these genes that it's producing might not be directly related to what we're trying to get. You have to always keep in mind that it's just trying to predict sort of the next most likely character, right? So one thing that might be common is that we do see a lot of genes from these same gene families. And even though they might work in similar modules, they might not be directly associated with sort of the disease or the topic that we're trying to get at. Well, how can we address this? Maybe we can ask for the actual citations that these genes correspond to. So how is it pulling these genes out? So in this case, if you ask it for sort of citations, and here we're looking specifically for genes that are expressed in the kidney, sort of a specific part of the kidney, you'll see it actually will produce these citations. So we do get these sort of brackets with numbers, and they correspond to links. And we can see, though, that for 60 here, which is the last gene in this list, this ATP gene, it's actually linking to sort of a completely separate gene page. So the thing to underscore here is that even if you sort of ask for citations and you ask for it to go sort of cite its work, where are you getting this information? It will still confidently provide you an answer, but that answer might be incorrect. So this is something really to keep in mind when doing these types of tasks. And then some other things that we notice is Like I said, it's generating the most likely next character. So if it's has stat one, stat two, stat three, it might just keep iterating on that, even if the next number of that gene doesn't actually exist. So that's something that we saw. Additionally, when asking for sort of longer sets, like greater than 100, it will basically not even produce an answer a lot of the time. So just some things that we've sort of noticed in experimenting with using LLMs in this sort of context. So just to overview, hallucinations is something you've likely heard about in the media, but specifically in this context, citations are often going to be misleading, non-credible, or just completely made up. And the information that it provides may be sort of partial or just inaccurate in general. And another thing to consider is that these are pre-trained, right? So you can remember what the P in GPT stands for. And so they're not going to be up to date with the most current information. GPT-4, for instance, was last updated in December 2023. And the GPT 3.5 models are actually a little bit older than that. So from a few months before. So these are things to keep in mind when using ChatGPT in any sort of research context. So there's certain ways that we can sort of extract better performance out of the model. And a field that's kind of arisen with the advent of these LLMs is prompt engineering. So there's some sites that actually like sell prompts, have a prompt marketplace to extract the best performance out of these models. And another thing to keep in mind is that a lot of the prompt uh, tricks that I'll share and different sort of approaches to it are going to be somewhat specific to OpenAI. So every company that develops these models put together guides and do a lot of testing experimentation on how to best get the performance out of their model. So just a side note. Um, so we can look in the example here and we see, two sort of related but very differently phrased questions. So we have like, what's the typical weather in New York City? And then a much more descriptive sort of prompt asking for certain types of the weather in Celsius, Fahrenheit, and Kelvin. Also looking at wind, humidity, precipitation, and we also are asking for this output in a JSON format, right? So there's various things you can add to your prompt that will basically ensure that the result or help ensure that the result is what you're looking for. So we have these different elements that you might want to consider when writing a prompt. You have your instructions. So that's kind of the most basic part, right? What is the task that where you want to perform? Any context the model should know. So often, if I'm writing a prompt that involves gene sets, I'm going to define that in either a system prompt or just in the prompt itself and say, hey, a gene set is a list of genes. Because though it might know that from all this textual data, it's sort of been trained on, it's helpful to sort of explicitly state that. And another thing that can be really sort of beneficial in this context part of your prompt is providing an example, specifically with a more complex sort of prompt that you're dealing with, where they may be sort of picking something or it's very explicit in the type of task that you're trying to get it to do. Then an example can come in a lot of handy. So you can say, hey, with this input, this is what the output would look like. If it's kind of a prompt template, so you're inserting different things into it, maybe running it multiple times, it's nice also to specify where the input will be, or this like this is the input, right? And finally, you can also think about what is the output that you want. Do you want a paragraph that explains its answer? Do you want strictly the answer, no explanation? Do we want this in a JSON format or a Python list format? These are all things to think about when sort of interacting with this programmatically. Another important note, especially with the newer GPT models, so specifically GPT-4, is that the system prompt is very helpful and it will be very adherent to the instructions that it receives in the system prompt. So what a system prompt is it's basically a message that you're appending to your context of your messages that tells the model what it's generally going to be doing. So this could be as simple as you're a helpful assistant. I'm sure that's sort of what the base ChatGPT on their site is looking for. It's like just something very general, or it can be very specific. So it can define what types of answers should you be responding to. What tone should you be using? How should you be executing these queries, right? So there's a lot of information you can put in that system prompt that will contextualize sort of the model, so then it doesn't have to be included in every user prompt. So it might be if you're doing something that has where you can message back and forth with it, that might just set up the base sort of requirements or what you're trying to get out of it. So this is something to consider and definitely look at, especially in that type of context. So just to sort of summarize, we want to be sort of clear and summarize our exactly what our task should be. You can specify things about the output, for example, the length of it or the format of it. Um, Providing examples is often helpful, and specifying exactly what you want the model to do and to not do. So if there's a specific type of a case in which you want it to not answer, or a general case in which you want it to not answer, then you can include that in your prompt as well. And the best way to really get, optimal performance is to incorporate these different techniques and then experiment with it and see what results you get, and then iterate on that prompt. And OpenAI has a really good guide on prompt engineering. Obviously, they've done a ton of testing on how to get the best performance out of their model. So definitely, if you're interested, I recommend looking more into that.